Get ready, because today we're going to explore puzzles that even the most sophisticated telescopes haven't solved yet. Let's unravel the celestial secrets together, the ones that keep scientists awake at night. And I'm not talking about caffeine, but pure cosmic curiosity. So, buckle up as we embark on this stellar adventure where each discovery is a surprise. Supermassive black holes are true cosmic colossi, often found at the centers of large galaxies. These mysterious entities have masses that can be millions or even billions of times greater than that of the Sun. One of the major questions that intrigues scientists is how these black holes reached such enormous sizes. The prevailing hypothesis suggests that they started as stellar mass black holes, which grew over time by accumulating matter and merging with other black holes. However, the exact details of this growth process are still poorly understood, particularly considering the delicate balance between the gravitational attraction that allows mass accumulation and the energetic radiation that could repel that same matter. Beyond their impressive size and mass, supermassive black holes play a crucial role in the formation and evolution of galaxies. They seem to significantly influence galactic dynamics, star formation, and the distribution of gases across a galaxy. This influence is primarily exerted through quasar jets and other forms of energetic radiation that emanate from black holes when matter is drawn into their event horizon. This process, known as black hole feedback, can regulate the growth of a galaxy by heating the surrounding gas and preventing it from condensing into new stars, although the exact mechanism and effectiveness of this feedback are still subjects of intensive study. The complexity surrounding supermassive black holes does not end with their formation and galactic impact. They also challenge our understanding of physics under extreme conditions. Dark matter is one of the most enigmatic and predominant components of the universe, making up about 85% of the total mass, yet it remains one of the most challenging phenomena for contemporary science. Its existence is inferred not by any emission of light or radiation that can be directly detected, but rather through the gravitational effects it exerts on galaxies and galaxy clusters. These effects include the bending of light from distant objects, a phenomenon known as gravitational lensing, and the unexpectedly high speeds at which stars orbit around the centers of their galaxies, suggesting that there is much more mass than we can directly observe. Scientists have developed various theories and experiments to try to capture the nature of dark matter. One of the main candidates for dark matter composition are WIMPs, weakly interacting massive particles, which, as the name suggests, would be particles that interact very weakly with ordinary matter except through gravity. Despite numerous attempts, no direct detection has been confirmed so far, and WIMPs remain hypothetical. Another theory suggests that dark matter could be composed of axions, hypothetical particles much lighter that also interact extremely subtly with ordinary matter. In addition to attempts at direct detection, scientists also seek to better understand dark matter through computer simulations and detailed astronomical observations. These studies help clarify how dark matter influences the formation and evolution of large-scale structures in the universe, from the earliest stars and galaxies to the vast galaxy clusters we observe today. These patterns of cosmic formation provide crucial clues about the properties of dark matter, including its distribution and how it might have helped shape the universe from the earliest moments after the Big Bang. Fast radio bursts, FRBs, are astrophysical phenomena still shrouded in mystery, characterized by brief and intense bursts of radio waves that last only a few milliseconds. First discovered in 2007, these signals are detected as sudden spikes of energy and originate from distant regions of deep space outside our galaxy. The ephemeral nature and massive energy of these signals intrigue scientists, who seek to understand not only their origin, but also what they may reveal about the universe at large. Various theories have been proposed to explain the origin of FRBs. One of the most accepted suggests that they could be the result of highly magnetic neutron stars, known as magnetars. These stars are the collapsed remnants of supernovas that, despite being only a few kilometers in diameter, possess extremely strong magnetic fields. Another hypothesis is that collisions between neutron stars or the collapse of black holes in distant galaxies could be responsible for these rapid and powerful emissions. Beyond conventional astronomical theories, some bolder speculations include the possibility that FRBs are signals from advanced alien civilizations' technologies. While there is no evidence to support this idea, the non-repetitive nature of many FRBs and the difficulty in tracking their exact origin fuel both scientists and the public's imagination. This possibility, though remote, highlights how little we know about the universe and how surprising future discoveries might be. Hogs object is one of the most fascinating and peculiar structures found in the universe. Discovered in 1950 by astronomer Arthur Hogue, it stands out for its unusual configuration. A bright yellow central core surrounded by an almost perfect ring of blue stars, with virtually no visible material connecting the two. This configuration gives Hogs object the appearance of a mysterious celestial ring, differentiating it significantly from the typical shapes of spiral or elliptical galaxies commonly observed. The formation of Hogs object and other ring galaxies continues to be a puzzle for astronomers. One theory suggests that ring galaxies like Hogs object may form through galactic collisions. In this scenario, a smaller galaxy could pass through the center of a larger galaxy, triggering shockwaves that push gas outward, forming the ring of stars. However, the almost perfect symmetry and lack of visible material between the core and ring in Hogs object challenge this explanation, suggesting that other processes may be at play. Another hypothesis involves a phenomenon known as resonance. In this process, gravitational interactions within the galaxy itself can lead to the formation of rings. Resonance occurs when gravitational forces within the galaxy act in a way that pushes gas and stars into an outer circular orbit, resulting in the ring structure observed. This theory could explain the clear separation between the core and ring in Hogs object, but it still requires more evidence to be confirmed as the main cause of the formation of this type of galaxy. Tabby's star, formerly known as KIC 84628552, is a star that has captured the imagination of scientists and space enthusiasts due to its peculiar light-dimming patterns. Initially observed by the Kepler Space Telescope, this star exhibits unexplained and significantly larger brightness dips than those caused by transiting planets, which are typically only 1% or less. The brightness variations of Tabby's star, on the other hand, can reach up to 22%, a phenomenon that defies conventional explanations and suggests a complexity not yet fully understood. Several hypotheses have been proposed to explain the strange light variations of this star. One of the earliest theories suggested that a swarm of comets could be passing in front of the star, blocking part of its light. Another possibility considered was fragments of planets or debris from planetary collisions in the star's orbit, which could create irregular dimming patterns. However, these natural explanations have difficulty justifying the extent and irregularity of the observed dimming events, leading scientists to continue searching for new theories. One of the most intriguing speculations around Tabby's star comes from the hypothesis that artificial structures, possibly an alien megastructure known as a Dyson sphere, could be causing the fluctuations. This theory suggests that an advanced civilization could be building a gigantic structure around the star to capture a significant portion of its energy. Despite being a fascinating idea, it is widely considered a last resort explanation in the scientific community, reserved for after all other more plausible hypotheses have been ruled out. I hope you enjoyed diving into the deepest and most enigmatic mysteries of our universe with us. Remember, each cosmic puzzle we explore brings us a little closer to understanding the infinite space that surrounds us. Don't forget to leave that like if you enjoyed the video, and subscribe to the channel so you don't miss our next journey among the stars. Oh, and of course, leave in the comments which cosmic mystery you want us to explore next time. Until then, keep your eyes on the sky and your curiosity ignited, because in the universe, the only certainty is that there will always be more to discover. Bye, and thank you for traveling with me.